So this is going to be 1.3 slide 8 on Desmos, or it's ready for more. It's right here, ready for more on 1.3. Same things. Hold on a second. I just erased that. That's supposed to be there. That's the answer, but it's not erasing. Okay, here we go. Okay, so when I'm trying to figure out the recursive of a geometric pattern, and now you know that this is geometric because it's not being plus something. And like, let's just back this up. They just said, find the recursive and explicit. What would you do, right? So the very first thing that I'm doing is I'm looking at this pattern and I'm trying to see how it's growing. And so it goes from 3, right? It goes from 3 to 6. And I'm like, oh, it's plus 3. And then I look and I'm like, wait a second, but 3 times 4 is 12. So no, it's not plus 3 because plus 3 here is not plus 3 here, right? So clearly, this is plus 3 plus 6. So that means it's not linear or arithmetic. Meaning I can't use y equals mx plus b, right? So then you're like, okay. So if it's not, don't tell me what it isn't, Miss Johnson, tell me what it is. So this is just my process notes, but then I'm trying to figure out, is there another way for me to get from 3, is there another way to get from 3 to 6 and from 6 to 12? And it's that same thing. And the answer is yes. Yes, there is. It's times 2. Perfect. Thank you in the chat. So here, this is the correct answer. It's times 2 times 2. And I'm looking for that pattern, that consistency. So, right, if this was a common difference, that would be my consistency. This is not consistent. 3, 6, not the same. So I'm looking for that consistency. 3 times 2 is 6. Yes. And 6 times 2 is 12. Yes. Okay. So what I like also to do is show you looking at the actual pattern. So this would be 1, and then this would be 3. This would be 2, and this would be 6. This, oh no, hold on a second. No, I don't need to translate it, sorry. I want table, and I want insert below, okay. And then this would be 3, and then this would be 12. And then you could see the pattern kind of continuing. So I'm gonna put a couple more just so that we can look at that pattern. So the way I look at this is that you said, oh, just multiply by 2. So I wanna tweak your brain just a little bit on how to do this. And I think we talked about this before. So instead of me looking at this as 6, I look at this as 3 times 2, right? I look at this 6 as 3 times 2. And instead of looking at this 12 as 12, I'm going to look at that as 3 times 2 times 2. Does that make sense? So let me catch this guy up here. It's not functioning. Whenever I'm in a hurry, that's what it always does. So then I want to get that. I want to write it out like that. So then this would be 3 times 2 times 2, right? And it's not catching up. I will make another column. That's what I will do to make this go faster. Technology, you're not going to hold. Oh, it's there. Now it's going to show up. Okay. So then if you notice, you'll see all of these 2s showing up. And remember, I was saying, I wish there was a faster way to write these 2s, right? And so the next one would be 3 times 2. Times 2 times 2. Every single time I'm just adding, or not adding, multiplying a 2, a 2, a 2. Right? A 2, a 2, a 2. So then I say, oh, is there a better way for us to write this? And the answer is yes, absolutely. Yes, ma'am. So then what I'm going to do is I'm going to write these as exponents. So I'm going to write this as 3 times 2. This one, I'm going to write this as 3 times 2 squared. And this one as 3 times 2 cubed. So part of me wants to say, okay, what is staying the same? What is staying the same? Okay, well, that 3, Miss Johnson, it's the same. Yes. Okay, Miss Johnson, that 2, the base, it's the same. Yes. Okay, now what is changing? The exponent is. And Ms. Johnson, is it okay if I write a little 1 there just to keep my pattern consistent? Yeah, and actually if you wrote this one out, it would be 3 times 2 to the 0, right? We just learned that 2 to the 0 was 1, or we reminded ourselves of that. And if you notice, that 3 is still there, that 2 is still there, and notice our exponent is the thing that's changing. Okay, that's the thing that's changing. So somehow my function is going to look like this, right? So if I put n down here, it's going to be 3 times 2, right? The thing that's going to stay the same is that 3, that 2. And then now what I want to know is, how do I get this exponent? So the exponent is changing based on the minute. 4 is 3, and 3 gives me 2, and 2 gives me 1. Right? So how am I going to get from here to here? And if you notice, it's just 1 away. Oh, okay, I can just put n minus 1. Yes, I could just put an n minus 1 as my exponent. Ms. Johnson, how did you know to put n minus 1? Well, because I can't put n, right? I couldn't just put an n here because it's not 3 times 2 to the 4th for this one. It's not 3 times 2 to the 3rd for this one. It's 1 down. So that's why I just subtract 1. So the thing that I want to impress upon you is 2 things. Number 1, figure out what's keeping this, what stays the same. And in this case, it's 3 times 2. And then I want you to figure out what is changing. And the thing that's changing is always going to be based on your minutes, or the X value here, right? Your N value. So how is that built on that? And in this case, it's not the same number. It's just minus 1.